Hey everybody, Mr. Stewart here at Math We've Got This, and in this screencast we're going to take a look at the distributive property. So in our first example, let's use a rectangular array in order to multiply 18 by 5. So if we take a look here at our rectangle, we could label one of the dimensions as 5, the other one as 18. Now the goal of using an array is to make the multiplication a bit simpler. So if we were to split the rectangle into two parts, we could label one length as 10 and the other one as 8. So we can see that the area of this portion would be 5 by 8, which gives us 40, and this piece here would be 5 by 10, otherwise 50. So the way we can write this down, so if we want to multiply 5 by 18, we could say this, be 5 multiplied by, so we'll open up a bracket to indicate multiplication, and we'll write in the 8 and the 10, or a sum of 8 and 10. So we now have a group that's being multiplied by 5. Now I did mention in the array we're multiplying 5 by 8. And we're also adding on to that area a product of 5 by 10, giving us 40 and 50 for a sum of 90. So 5 multiplied by 18 is equal to a product of 90. So what you'll also notice, let me grab a different color here, is that this line here, line 2, if we weren't working with the array, what we could do is to say, in order to drop the brackets, right? So if we want to remove brackets, the only way we're going to do that is if we distribute, which means to multiply that multiplier, or the 5, by the 8, and also multiplying the 5 by the positive 10, which we have here. And that's how we arrive at line 2 in our solution. Other things to take note of, and you'll hear this throughout the video, you'll notice here that there are two terms in this group. Okay, we can refer to that as a binomial, meaning there are two terms in the expression. Here we have one term, so the multiplier is just a single term. We'll refer to that as a monomial. Altogether, they are part of a class of expressions known as polynomials. All right, well, there's our intro. Now, let's add in some variables. So let's use the array to multiply the following. So multiply x over the group x plus 2. Well, let's label this dimension as x, and this as x, and the remainder of that sum would be the 2. So here we'd have a product of x multiplied by x. It's also called a partial product. And here the second and other partial product would be x multiplied by 2. Or the same as saying 2 multiplied by x. So therefore, this would now be equal to x squared plus 2 times x. And the reason why is we've applied the distributive property. So we've taken the multiplier and we're multiplying it into the group. So x multiplied by x is x squared, and then x multiplied by the positive 2 gives you positive 2x. Now let's add a coefficient to our multiplier, or to the x. So let's have a 3x term, and we'll change this up just a little bit. So we'll label this dimension as 3x, and this as x, and then the rest of that length or term, we'll put the plus 2 here. And we don't really have to add the plus 2 in. We can understand that the length is the sum of x and 2. So let's fill in the array. So we'd have 3x multiplied by x, and then we'd have 3x multiplied by 2. So this would give us, remember, x times x. If you like, you can indicate there is an exponent of 1 on each x. So then the exponent law for multiplication would tell us that's x squared. So this will give us 3x squared. So that would be the area of that small rectangle. And over here, double 3x, and we'll make 6x. So then this, when we use the distributive property to multiply, sometimes it's called expanding, we would have the product of 3x squared plus 6x. And again, we applied the distributive property in order to remove brackets. So in order to get rid of these, the only way to do that is to multiply 3x over the x, and then multiply it also over the rest of the group. So that other term, plus 2. All right, let's keep on going. And you'll notice there's some patterning involved here. So I'm keeping the same format, the same build for each expression. Reason being is we just want to practice some of the exponent laws. So here's a 3x, an x squared, and then a 2. Well, we know what this one is. 3x multiplied by 2, that'll give us 6x. So that's a really poor looking multiplication symbol. Let's try that again. We'll erase that. And we'll put in a better looking dot notation for multiplication. There we go. That's better. And then that gives us 6x. Over here would be 3x multiplied by x squared. And again, if you like, you can put a 1 on this x here, and then according to the exponent laws, we would add those exponents. So 1 and 2, given the bases are the same, we'll add them up. That'll give us an x cubed. So we'd have 3 multiplied by x cubed. So then therefore, using the distributive property to expand, which is just a fancy word for saying multiplication, we'd have a product of 3x cubed plus 6x. And again, that's all made possible by the distributive property. So we distribute 3x, that multiplier, over every term in the group. All right, so we'll end the video there for part 1. We'll come back with part 2 in just a few moments.